this is to help you with your test corrections. Remember, you can get a maximum of 5% back, and it kind of depends on how well you not only fix your mistake, but describe what you did wrong. So I'm not going to put every single thing on here. I'll probably correct this to like a 3% and leave some stuff off, but for Rolle's theorem, there's 3 criteria, and I would check them in order. The function needs to be continuous. The function has to be continuous on the interval. Okay, so basically we're talking about no asymptotes, unless it's a piecewise function, and we have to look and make sure there's no holes in the graph. Differentiable on the interval, and then for Rolle's theorem, this is the MVT. Rolle's theorem requires that we start and we end at the same height, and it guarantees some place where that slope of the tangent line is 0. However, this fails the very first criteria. So we have a vertical asymptote at x equals -5. You have to state where that discontinuity exists on the interval, because otherwise it's sort of considered like you could know that continuity is one of them, and since it says does not, you could just guess, well, it's either not continuous or not differentiable. You could just guess. So you have to say not continuous at x equals -1.5. You should actually even say that that value is in the given interval. Some of you wrote that there's a vertical asymptote there, and I gave full credit for that. The next one is calculator active. Keep in mind that it asked from 0 to 10. The hint said to sketch it on this. I didn't make this problem. I don't normally write these exams, so I almost think that that hint messed a lot of you guys up, because what happened, and you're going to have to go graph this. This is the derivative, and critical values are where our derivative equals 0 or doesn't exist. So you're looking for where that f prime equals 0, and a lot of you said 3. This isn't the graph, by the way, if you sketch this, although you did not go to your calculator and do the actual function. But there are a lot of you who put 3, neglecting that the interval given was from 0 to 10, and it only happens once. So if you're fixing that one, you should actually sketch the graph of f prime. I made a fakie. All right, so this is the graph of f prime. I always like to write my y values representing f prime. I am on an open interval from -4 to 6. A couple of you lost halvesies because your answers, you included the infinities, and this is a domain restriction, and so you can't leave that domain. We want f to be increasing. For a function to increase, its slopes, its derivatives, must be positive. Well, my y values are the slopes. So basically, I'm looking above the x-axis, right? Here, my f primes are positive. Here, my y values, which are f prime, are positive, and right here. So in red are all of the areas on that graph where f must have been an increasing function. But it also says, and concave down. This means f double prime must be negative. This means f prime, because that's what my graph is, must decrease. For its slopes, okay, to be negative, f prime must decrease. Right here, f prime is positive, its slopes, f double, are negative. And right here. And don't put negative infinity, -3. We would say -4, -3, union z, what is that, 1, 3 over there? Yeah, union 1, 3. And then because, some of you also lost some justification points, because you didn't use f prime. So that's where when you describe what your mistakes were, if you use as the subject of your justification anything but f prime, I took a point off. The subject of the graph is f prime, and I need to know what f prime must be doing. So we should say because f prime is greater than 0 and f prime is decreasing. Okay? There we go. Nothing, you don't put f double prime as 0. For that to happen, my graph must decrease. So there's that one. I should probably put the point values on there. That one was out of 3 points. This one was out of 2 points. One for the justification where critical values exist, and one for identifying that there was just one of them. All right, this one nobody really got wrong, so I am not going to discuss that. The next one, number 5, there is one common error, and that's all I'll discuss. Otherwise, number 5 went great as well. Many of you said that there were inflection points at 0, -1, and 2 because this was where f double prime equals 0. Remember that inflection points, you're not guaranteed one when f double prime equals 0. Those would be called our possible inflection values. So this is actually not correct, and so I would have given you 1 out of 2 points for that because you need to analyze f double prime. You need to analyze it in these intervals because we need, not only does f double prime need to equal 0, an inflection point occurs where there's a concavity change from concave down to concave up, which means our second derivative has to change signs, okay? So we find where our second derivative is 0, but then we do a sign test, and if you did that correctly, it went like this, and excluded 2 from your answer, and it's not because f double prime equals 0, it's because it changes. So those were each worth 2 points. I actually didn't give a point for the inflection. So I gave 1 point if you put all 3 of these, and 2 points if you outrode the 2, but you didn't need the justification on this one, or the one above it because it didn't say. All right, then we had our FRQ. This went great. So, I'm going to gloss over it pretty quickly. Our function is increasing when its derivative is positive. I am graphing the derivative. So this would have been on the interval from -2 to 4. And it would have been because the derivative was positive. Now, some of you excluded this point. The second derivative doesn't exist there. But f prime of 0 is the y value there, which was 2. And so f prime does exist. There is a dot there, so be careful of that. Next up, it says a relative minimum. We know that f prime needs to change from negative to positive. This occurs at -2, so you'd say that x equals -2 because f prime changes from negative to positive. These were each worth 2 points, 1 for the correct answer or 1 for a good justification. On what intervals is f concave down? We gotta think, what do I need? Okay, I need f double prime to be negative. If you put that for your justification, I didn't give it to you because I consistently said in this chapter, the subject of your justification has to be the subject of the graph. So I have to say, well, what does f prime need to do for f double to be negative? Decrease. So you should have said that we are concave down on 0 to 2 because f prime is decreasing. And what's our next one? Part D, inflection points occur when f double prime changes sign. F double prime changes sign. F double prime is positive because f prime is increasing. F double is negative. This can occur. Remember that it occurs at places where f double prime equals 0 or does not exist. So we would have said at x equals 0 and at x equals 2. I took 2 justifications for this. This is where f prime changes from increasing to decreasing or from decreasing to increasing. Some of you said this is the relative extrema of f prime. That was also full credit. Our last one, an equation for a tangent line requires a point. We say y minus the y I know is equal to the slope there, which would be f prime of -1 times x minus 2. You obviously can't leave this. We need to go figure out what f prime of -1 is. Well, my graph is the graph of f prime. So if I go up here and I say what's f prime of -1, it's up at 1. Again, my y values are f prime. So you needed to just put a 1 here. Just leave it. One poor person cleaned that up and said, what did they do? Instead of adding 2 to both sides, subtracted 2. So be careful because you lose that point. That was with 2 again. 1 for point slope form and 1 for the correct slope. That's it for the white. All right, moving on to our yellow. which I did the most missed in elk time and linked that. All right, so our first one was G prime is always negative, F prime is given. I don't need to take a derivative, okay? I'm dealing with relative extrema. I need my critical values, which is where F prime equals 0 or does not exist. And then I analyze, keeping in mind that I'm going to cross this out. This is negative all the time due to that. So if I were to put in a negative 3, okay, I would have 9 minus 4, which is 5, times a negative. We would be negative in that area. Any number there would have given me 1. Most logical thing to choose for this interval would be 0. 0 minus 4 would be negative 4, but remember, G was always negative. Likewise, you can do the sign analysis. So that would have been at B. We have a minimum at negative 2. F prime went from negative to positive, which means F went from decreasing to increasing, and then from increasing to decreasing. The correct answer for 2 points was B. Number 8, a function increases when its derivative is greater than 0. That actually is the justification right there. So if you wrote that underneath there, even, I'd give you full credit as long as I saw it. I think on Izzy's, she wrote it there and I didn't see it to point out. I gave it back to her though. So you need to take the derivative. You need to set it equal to 0. We always factor, and we always get as a single fraction. This factored beautifully into an x plus 3 and an x minus 1. It gave us 2 critical values. Those needed to be analyzed on a sign line and checking to see what's happening with f prime, because if f prime was positive, I am increasing. I do a sign analysis in f prime. When you do so, and again, I shouldn't need to teach you how to plug in negative 4 into this function, right? So f would have been increasing on. There's no domain restriction, so we would have said negative infinity to negative 3 union 1 to infinity. This was worth 4 points. If this wasn't here, which some of you got 3 out of 4 because you didn't do the justify, remember I told you that for AP, they tell us when we're readers, you be sign line blind. So you pretend the student didn't even make a sign line. That is not the justification. That's how you decide where f prime is greater than 0. So the first point was for the derivative, second was for the factoring, third was for analyzing, and then, correct answer, and then fourth was for the reason. Number 9, almost nobody got wrong. It was D, but just a couple little things about this. You know from pre-calc and algebra 2 that that was probably a cubic, x cubed plus something something. Cubics derivatives, regardless of even what's happening here, go to parabolas. So this is out and this is out. All I need to do is figure out which parabola it is. But remember, when I'm graphing f prime, I'm graphing, slopes. So slopes over here are positive, so my y's must be positive. Then the slope was 0, so my y must be 0. So it kind of locks you in to D over there. This was worth 2 points. If you chose B, I gave you 1 out of 2 just for recognizing it was a parabola. I don't think anyone chose A or C, so there were no zeros out of 2's on that one. My next one, so that one was worth 2 points. This one, next one, was also worth 2 points, basically an all or nothing for this guy, but these are the derivatives of 3 functions, and which of them have a relative maximum? That means the derivative needs to go from positive to negative, which means from above to below the x-axis. My derivative here, negative, negative, 0, negative, 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 0, negative to positive, realm in, boom. This one has right there the location of. None of the others ever cross the x-axis from above to below. So F only for 2 points. That was either 2 out of 2 or 0 out of 2. Number 11, okay? This one had a lot of you who chose C. So if you did that, I really need you to listen, because you really have to be careful about thinking that when a second derivative is 0, you have an inflection point or a change in concavity. That's not true. Here's a function x to the 4th. Its first derivative is 4x cubed. Its second derivative is 12x squared. So its second derivative is 0 at 0. But to the right, we're positive. To the left, it's positive. That means this function is concave up. Its second derivative is positive on its entire domain. If you were to graph that function, x to the 4th, it looks a lot like x squared, except it kind of glides along a little bit longer. But there's no change in concavity here. So be careful with that, because with this problem, you ended up having, so when you took your second derivative, so again, this one was worth 3 points, one for taking the first derivative, or sorry, getting the second derivative. I didn't get one for the first derivative, because if that was wrong, so was the second. So I just gave one for this nice second derivative right here. We always factor, and we always write it as a single fraction. So a lot of you said, oh, that's 0 at 0 and 1, and you went and circled C. However, when I do a sign analysis to see what's happening with concavity, because an inflection point is where the function changes concavity, which means its second derivative must change signs. And your sign line for the second derivative would go negative, negative, positive, which means concave down, concave down, concave up. So there was only a change in concavity, aka an inflection point, at 1. Our absolute maximum requires a candidate table. A function can reach its absolute maximum or minimum anywhere where the derivative equals 0 or doesn't exist, or at an endpoint. Absolute max, absolute min. So we need to, on our table, this was worth 4 points, okay? The first point was for knowing I need a candidate table. So a couple people didn't actually make a table, but you did f of -2 and f of 4, and you wrote them down. So I was looking for those. This ended up being -8. This ended up being 28. This is now a candidate for absolute min. This is a candidate for absolute max. If that is the lowest it ever was, that's my min. 28 is the highest it ever was at the very end. That's my absolute max. I need to now find all those turning points. Any place where the derivative equals 0 or doesn't exist, also known as my critical values. So I end up with, we always factor, I end up with 2 critical values of 0 and 2. I don't make a sign line. I want to see how high the function was at that critical value and how high the function was at that critical value. They go in the actual function. Some of you were putting them into the derivative. Okay? They go into the function. I'm looking for the maximum value of that function. When I put a 2 in here for x, I get an 8. So here we are. The absolute maximum is 28 at x equals 4. So 4 points for that. I wanted a table. I wanted correct values in the table. I wanted critical values, and I wanted a correct conclusion. Okay? Where's my page turner? 13 was already done, so this video is linked on our daily slides. I did that in out time. Number 14. I like number 14 a lot. F is a function that's defined and continuous, so I never lift my pencil. I don't have any asymptotes or anything. I might have a cusp because it just says defined. It doesn't say differentiable. So like this function right here is defined at 2. It's just not differentiable there, so keep that in mind. If F has a relative maximum, okay, at C, what must be true? Do all relative extrema occur where the derivative must exist? No. We can have a relative maximum where the derivative does not exist. That's why our critical values are defined as anywhere where the derivative equals 0, these turning points, or does not exist. We sometimes forget that because on most of our analytical problems, we don't really get any candidates from the D and E, but it's still part of the definition. If the derivative does exist, then it must be 0. Well, yeah, if the derivative did exist at my maximum, it must have been 0. This is a yes. If the second derivative exists, talking about concavity, then the second derivative must have been negative. Must I be concave down at an absolute max? Yes, that's the second derivative test. So this was D, and that was worth 2 points. There are very few people who got 1 out of 2. I gave 1 out of 2 if I saw you trying to analyze this over here. Just a second, I have to pause and plug in my computer. It's low on batteries. Alright, I'm back. So our next one, 15, I also already did an ELK time. It's also on that same video. And again, if you're wondering where that is, go to our daily slides for the week of the 9th through the 13th. And one of those slides talks about test corrections, and this video is linked right above where the one you're watching was. Alright, so number 16. 2 points, 2 points, because the interval needs to be correct with a correct justification. So these were each worth 2. This is the graph of f double prime. All my y values represent what f double prime was. On what intervals must f have been concave down? Which means its second derivative must have been negative. Concave down like a frown when we get a second derivative that's negative. But my y values are my second derivative. So I needed to have negative y values or be below the x-axis. So you would have said I'm -3, -1, union 3, 5, because in the subject of my graph is f double prime. So you can just say, because f double prime is less than 0. On what values? And again, a couple of you wrote -1 to 3. Well, that's where f double prime is concave down, which means its second derivative, which would be f quadruple prime, had to be negative. So be careful about what level you're on. Where did f have inflection points? What happens at inflection points? F double prime equals 0 or doesn't exist and changes sign. So basically, if f double prime is my y-axis, and I need f double prime to change, not my y-axis, my y values, f double prime changes signs here, 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 here. So we would have said -3, -1, 3, and 5 because, and if you wrote f double prime equals 0, I did not give you credit for that because had this bounced off the x-axis, then I wouldn't have included this one. We need f double prime to change signs at inflection points. Number 17 is also on a video, except for part A. Otherwise, I discussed the rest of that in the video that I did in ELK time. Very few people got part A wrong, but just in case, this is my first derivative. I want a single fraction, it is. I want it factored, it's not. So I'm going to go factor that top. Okay. The reason I'm doing that is because for relative extrema, they have to occur at critical values, anywhere where the derivative equals 0 or doesn't exist. I'm going to cross this one off, though, because of that. If you didn't do that one, if you still kind of analyze that, I don't think I took any points off, but this is saying we're going to only be positive for the domain of this function. Alrighty, so at 8, I'd have to decide if I had a max or a min. That's where my sign line comes into play. So on 8 and on at 2, my derivative was 0, my derivative was 0. This actually would be a 0. That's going on to infinity if I kind of wanted a really accurate sign line. So you would test, I'm not going to do that, you'll test probably a 1, maybe a 5, maybe a 9 in f prime, and Anywhere where f prime changes from positive to negative is the location of a maximum. If f prime changes from negative to positive, then f must have been decreasing. If it slopes, f prime changes from negative to positive at a place where the derivative was 0. The rest of this was done on a different video. Okay, so if you need any extra help on your corrections, you can feel free to come in and ask me. Hopefully the video was enough to kind of jumpstart those corrections. Have a good one, guys.